So we've got a question here. We've got a curve, y equals the square root of x, and there's 2 points on it from 4 to 9, which obviously correspond to the y-axis of 2 and 3. So this point here will be y is 2, that there will be y equals 3, corresponding to the 4 and 9 values of x. And there's a shaded rectangle inside with height y and width delta x, so it's a very small amount of value of x, and this point P lies on the top of it, and it just, as it's a rectangle, it doesn't quite just touch the whole of the curve, just this corner touches the curve. So the question is, we need to calculate the limit as this width goes to 0, and need to sum it over from the range of x is from 4 to 9 for the square root of x times that change in x. Okay, now what this is asking us is what's the area under this curve from 4 to 9. Now there's a couple of methods which we can use. We can use the trapezium rule using summation, or we can just turn this into an integral. As this is continuous over this curve, we can just go straight into a line integral. So now we've got the integral using the range of this summation. So we've got 4 and 9. Put in the function square root of x and then dx. Okay, now when integrating, I like to write these as an indice. So instead of square root of x, I can write that as x to the power of a half. So now I'm going to just rewrite that, 4 to 9, x to the half dx. Okay, now to integrate this, that's pretty straightforward from here. I could just raise the power by 1. So let's do that. So raise the power by 1 and then divide by the new power. So divided by 3 over 2. And then we calculate the value of that from the range of 9 and 4. So 9 and 4. Okay, right. Let's just simplify that up a little bit. So this now becomes, so if I bring this back down to here, I've now got 3 over 2 in my denominator becomes 2/3 as a multiple, times x. Now 3 over 2 is the same as x cubed, but the square root of it. So I've got x cubed and then the square root of it. Okay, so to calculate that from the range of 4 to 9. So let's do that. Okay, so let's first of all, let's plug in 9, and I'm going to keep this constant multiple of 2/3 out front of all the calculations. So I've got 2/3, and then when x is 9, I've got the square root of 9 cubed minus the value when x is 4, so that's the square root of 4 cubed. Okay, well 9 cubed is 729 and 4 cubed is 64. Okay, now square root of 729, that gives me 27, so I can just write that as 27, and the square root of that would just give me 8. So basically what I've got inside here is 27 minus 8, which is 19. So then I've got 2/3 times 19. So if I just keep continuing these along, 2/3 times 19, which equals 19 times 2 is 38, so it's 38 over 3, which equals 12 and 2/3. That will be good for my answer. Basically, that would be the area under this curve, under the curve y equals square root of x from 4 to 9, using either this method or this method. Okay.